Dear friends, we are getting the another problem on a particular fin. I will read the problem. The aluminum square fins 0.5 millimeter into 0.5 millimeter. It is a naturally square section 10 millimeter long are provided on the surface of the fin of the semiconductor electronic device to carry 1 watt of energy generated. So this is the square fin. You can see this is the square fin, and here you can see the square W means width, W, okay. And here, 1 watt of energy we have to transfer, it has to transfer, total. So, number of fins are there, we don't know what are the number of fins. One fin we have shown on the diagram. The temperature of the surface should not exceed 80 degrees centigrade. And the surrounding temperature is 40. Surrounding temperature is 40. Thermal conductivity of the aluminum, you can see that thermal conductivity of aluminum is 15. The thermal conductivity of the aluminum is 200. And the convective heat transfer coefficient is 15 watt per meter square degree centigrade. Watt is missing here. Determine the number of fins required to carry the above duty. What we have to do is here. So here, all the things are given, and neglect the heat loss from the end of the fin that they have mentioned. So now one by one we have to see. So it is a square fin, naturally 0.5 into 0.5, cross section is square one. The length of the fin is 10 millimeter. All the things should be converted into SI system, that is meter square, meter, etc. And it is provided for the electronic device. Electronics device may get heated, and it will generate 1 watt of energy that we have to release it to the environment. Else, otherwise, the electronic device will have the high temperature, shoot up to the high temperature, and it may disintegrate into the wasteful thing. The temperature of the surface of the device should not exceed 80 degrees centigrade, because that is a limit. If it goes beyond 80 degrees centigrade, then it is disastrous. When the surrounding temperature is 40 degrees centigrade, it is given. Thermal conductivity of the aluminum is 200 watt per meter degree centigrade. Convective heat transfer coefficient, if it is surrounding is air, naturally H is equal to 15 watt per meter square degree. Watt is missing here, watt per meter square degree centigrade. Determine the number of fins required to carry out the above duty. When they are calling as plural term, fins means number of fins are more than one. So one fin is not sufficient. In which case the number of fins are increased when the one fin cannot provide the heat release capacity. Then we are going for multiple fins. Also, when there is a space restriction is there, we are going for multiple fins. The good example is, you can see surrounding the electrical motor, long longitudinal fins are provided. So one fin is not sufficient. Throughout the circumference, we can see the longitudinal fins. So one fin cannot complete the duty to release the energy. So many fins are there. Neglect the heat loss from the end of the fin. So we are neglecting the heat loss from the end of the fin. Means it is almost fin is insulated at the end. That is the case. Now what is the task is total heat to be transferred is 1 watt. This is important. Total heat transferred by the entire fin. Entire fin means how many number of fins are there? Combinedly, it has to transfer 1 watt. Perimeter means what is perimeter? Addition of all the sides. What is it? It is a square section. Square section means what? Each is 0.5. 0.5 plus 0.5 plus 0.5 plus 0.5. Means how many 0.5s are there? 4 0.5s. 4 into 0.5. It is in millimeter to be converted into meter by multiplying 10 raised to minus 3 meter. So one thing, perimeter means addition of all the sides. 0.5 plus 0.5 plus 0.5 plus 0.5 means 4 times. 4 into 0.5 and multiply by 10 raised to minus 3 to convert millimeter to meter. Now area. What is area? Cross section. What is the cross section? Square area? Square means 0.5 into 0.5. Both are same. 0.5 into 0.5. So 10 raised to minus 6. Why 10 raised to minus 6? Because we have to convert it into meter. So 0.5 into 10 raised to minus 3 and again another 0.5 into 10 raised to minus 3, together 10 raised to minus 6. It is 2.5 into 10 raised to minus 7 meter square. So here P by A, perimeter by A, it has been given. Perimeter by, what is perimeter? That is 4 width, 4 into width. What is 4 into width? Width is 0.5 only. And what is area? 0.5 square. So 0.5 and 0.5 square cancel. It is W we have taken. So 4 by W. W is how much? 0.5. Width is 0.5. So 0.5 into 10 raised to minus 3 for meter. 4 by that is means P by A is equal to 8 per meter. So M, now our constant is root H into P divided by K into A. So H is available, that is 15. So here convective heat transfer coefficient. Why convective heat transfer coefficient is given? Because heat is released to the surrounding air. So naturally, whenever there is a fluid, naturally H will arrive. So that is 15 is given. What is the perimeter? P by A. P by A is already, this is P by A. This P by A is already calculated. So 8,000. And P by is already calculated. K is 200. So naturally the M is constant. M is 24.5 per meter. So now we have to go for M into L. What is M? Already 24.5. And L, what is the length of the fin? Is 10 millimeter long. 10 millimeter long is multiplied by 10 raised to minus 3. For what purpose? Naturally to convert it into millimeter, from millimeter to meter. So answer is 0.245. So heat transfer per fin, individual fin, how much heat transfer is there? That is root HPKA theta B tan HML. So you should not be confused. H means already convective heat transfer coefficient. That is 15. Already it is given. Already it is given. Here 15 is given. So here also 15 is given. Then P, perimeter is given. What is perimeter? So 4 into 0.5 is 2. 4 into 0.5 is 2. 2 into minus 10 raised to minus 3. That is given. Then thermal conductivity is 200. Okay. And here area, what is the area? 2.5 into 10 raised to minus 7. That is 2.5 into 10 raised to minus 7. This area. And theta B, theta means temperature difference. Don't confuse. Sometimes theta B is given in some data book. Sometimes temperature difference is given. Difference is given. Theta means temperature difference. Here, what is the temperature difference? 80 is the high temperature at one end. 80 is the high temperature, and surrounding temperature is 40. So natural 80 minus 40. Temperature difference. That's all. Tan hyperbolic of M into L. M into L already we have prepared. That is 24 into 5 into 10 into 10 raised to minus 3. That is 0.245. Now what will happen? The heat transfer rate is 0.012 watt per fin. Per fin means per individual fin it will dissipate 0.012. But how much we have to work out? We have the target of 1 watt. One fin is able to only give up the heat of 0.012. Then naturally number of fins has to be increased. This is justified. So number of fins we have to increase because one fin can only dissipate the heat of 0.012 watt. Now number of fins required is equal to the given task is 1 divided by 0.012, then 83.33. Number of fins required is equal to the given task is 1 watt, and the individual fin will operate only up to 0.012 watt. It will dissipate this much only. Naturally 83.33 number of fins we have to provide, but 83.33 fins are not possible because it is always a correct number. Okay, this decimal number is not permitted in such number of fins. Therefore 83.33 means approximate is equal to 84 fins we have to provide to maintain the electronic device, not to go for heat shoot up. It will make the entire electronic device to be burst into pieces if it goes that particular temperature. It should not exceed 80 degree. Also, it should dissipate the heat 1 watt. So fins should be given how much fins? 84 fins. Then only the electronic device will be very, very safe. So understand the problem along with the theory. Always I have given the things. Okay.